Hi, everyone. My name is Christy Smith. I have Ken Leitner with me, and welcome to this Siege presentation on Zero Trust Security for Developers. We'll be talking today about what Zero Trust is, and probably more importantly, why you should care about it. In brief, the struggle between security teams and the threats that they face is a zero trust game, one where a gain on one side directly translates to a loss on the other. Now, as a developer, you're an active player in this game, whether you know it or not, and so every time you are able to zero out an assumption, you win one for your team. Now, we have a straightforward agenda today. I believe in very straightforward agendas. We'll cover the who, the why, and the what, where, when of Zero Trust and how to get started using it. So let's start with who we are. My name's Christy, and running analyst relations, I spend an awful lot of time talking about Zero Trust. I'm currently getting a certification as a Zero Trust security practitioner. Ken has experience within the gaming industry, and he's a prior Siege speaker. Currently, we both work for a company called Ionic Security. And at Ionic, we work with architects and developers at some of the largest and most highly regulated organizations in the world, helping them improve their data security. But Ionic actually started in 2011 as a company called Social Fortress when our founder, Adam Getty, got fed up with resetting his Facebook privacy settings. Every time the company rolled out a new control, they rolled all of their users back to the default, which was as open and as permissible as possible. Social Fortress began with a browser-based encryption extension that allowed users to maintain their own privacy and security. And this addresses a fundamental lack of trust in social networks and other systems that are built around harvesting user data. Now, the consumer market wasn't ready for this sort of zero trust in 2011, but securing sensitive information is something that larger organizations have been trying to solve for years. But let's not beat around the bush. It's Sunday, and Siege has been awesome and inspiring, so why the buzzkill? Why should you even care about security in the first place? Ken?
So the gaming industry has definitely had its share of historical breaches, and you'll find they have done significant damage both to revenue and reputation. While the leaked source code from Half-Life 2 many years ago might have paradoxically boosted awareness in the game, breaches can multiply development time, halt gameplay, and get you dragged through the press like the Webkinz breach earlier this year, which triggered a COPPA concerns, which is a Children's Online Privacy Protection Act. The lawyers in the room will be familiar with the evolving regulatory landscape. Privacy regs like GDPR, General Data Protection Regulation, can cost you up to $20 million or 4% of your revenue in fines, whichever is greater. The CCPA, California Consumer Privacy Act, opens up a private right of action that lets individual consumers sue a company directly for mishandling personal data.
Absolutely, and that GDPR is actually 20 million euros, or 4% of global revenue. So that's an incredible amount.
Personal data is the term used by GDPR. We use here PII, or personal identifiable information. Maybe you think this isn't a concern because your company outsources personal and financial data to external vendors, but your company is still responsible for the safety of your entire supply chain. If your users access third-party payment processors through your web portal, then customers will still hold you responsible. But the real reason you should care is that it's your data being stolen. It's your players' data. Cyber criminals' real objectives are often follow-on phishing attacks to exploit this personal data. And if they've gotten plain text passwords, especially if those passwords are reused, as a customer might do between your game account and their financial login, then real damage can be done. It's also important to consider your game's entire ecosystem. Twitter's on this particular slide because they had a high-profile attack this summer where outsiders gained access to an internal support tool. As gamers, we should be familiar with internal support tools, after all. And that allowed them to bypass two-factor controls and access verified accounts, including direct messages. Chances are you have these same support utilities for your game, and they're internally built and proprietary. What would be the impact if someone similarly got access to plain text passwords and was able to log into your support tool? They could sell off accounts and sell off accumulated inventory and unlockables. And what would that do to your game's reputation? And what about player or developer forums leaking private messages? If I'm logged into a game playing with a friend, I consider those chat messages reasonably private. And if those were posted on a social media site, the consequences would be considerable, and the reputation of your game would suffer. And here's the added problem. You're probably not well equipped. Consumers are demanding more and more security and privacy, but the leading computer science programs aren't equipping engineers to be successful in meeting these demands. Security is considered an afterthought in most organizations, especially game development organizations, much like sound design used to be in the early days. Regulated to bolt-on security testing, a waterfall approach to security tends to screw up everybody else's agile plans. Application architectures are rapidly changing, and so are cloud services and the capabilities needed to secure them. You don't have to play the game this way. When you start with engineering security and privacy by default and by design, innovative new technology becomes more accessible.
Thanks, Ken. That leads us into zero trust, which is an industry term used to describe a security mindset, and it's a significant shift from earlier models. The National Institute of Standards and Technologies, or NIST, issued a special publication earlier this year giving the practical definition of zero trust that you see on the screen here. Yes, I spend my weekends reading special publications by NIST. I don't know what I've done in my life to deserve that, but here you are. Ionic actually provided feedback as a part of this process, and NIST's revision of their document is still very network-oriented. They did adopt a number of our recommendations, and one of them was that authorization is a critical capability for delivering zero trust in the face of these networks that are viewed as compromised. And we're going to talk a lot more about authorization in the next session. Now, the lingering network focus that NIST and others have isn't really a surprise, because the term originated out of the Jericho Forum's debates on what they called deperimeterization in 2003. It's a really catchy term, but basically they were talking about the death of the perimeter firewall. Cloud technology was new. Companies were beginning to store data or consider storing data in the cloud, and so all of a sudden the ways in which security professionals had secured these assets had to change drastically. Forrester Research coined the term zero trust in 2009, and it became synonymous with innovations at the time called next-gen firewalls, or NGFWs. Now, these early computer security paradigms prior to zero trust and the advent of the cloud relied on concept of moats and walls. And so here, users authenticate into a domain, that gate you see in the center, using a login and a password. Once they're inside, though, they have complete access to all the resources there. They're trusted. A hacker breaching the walls or an insider threat who's already inside the trust zone, they get free access to everything. Now, these always were concerns with early security models, but when cloud services began offering all of these new cloud-based innovations, they really complicated the game. Now, these distributed architectures mean that somebody else is the one who's building most of my defenses. Companies like Amazon or Azure or Google may be able to build a way more powerful infrastructure than I ever could personally, but let's face it, I can't completely trust them. And besides distributed architectures, we also have distributed users. Humans are living and working and gaming remotely more than ever these days, thanks COVID. So there's been an explosion as well of other identity types like Internet of Things, IoT devices, and application services. Trusting all of these different identities can vary based on a myriad of different factors, from a user's group or role to the risk score of their device. There's a lot at play here, but the upshot is trying to protect your information with a firewall is about as effective as building a moat in Call of Duty. It is just really not going to do you any good. Now, in 2018, Forrester expanded their definition of zero trust into the diagram you see in the bottom right of your slide. 5 pillars. Networks is here. People, workloads, devices, and data. Data is the central pillar, and it kind of overlaps the others. Encircling these are 2 rings of visibility and analytics to data across all of these locations, and automation and orchestration. Everyone has jumped on the ZT bandwagon to varying degrees since, and that's really because there are some indisputable imperatives that have emerged around handling implicit trust, resource-centric controls, contextual decisions, and automated authorization. So what does it mean to do zero trust? I call this the interrobang slide because whenever somebody tells me to do something, my gut response is, but why? Question mark, exclamation point. So why should you reduce implicit trust? Well, it's because your trust walls are going to get breached. It's really a matter of time, and you need to minimize the blast radius of what happens when they do. Why should you design resource-centric controls? Because resources can be accessed from anywhere. The data that we have travels everywhere from my computer to the cloud and beyond. And so trying to maintain controls in all of these places, trying to put controls in place on the internet as a whole is ridiculous. It's not something that you can achieve. The third imperative, why should you create context-aware applications? The simple answer is because context matters. Thinking about that support utility example that Ken talked about earlier, if Twitter had limited accessing that support utility to only users coming in from trusted locations or low-risk devices or any other factors that were important for them to consider, those types of requests should be treated completely differently than somebody who's using random Tor browser, unsecured Wi-Fi that's coming out of band, so to speak, from another area. There are lots of different bits of information that you can use to put together the context of how a request is being made. The fourth imperative is why should you externalize authorization? And this one really speaks to the fact that once you code something, there is a tendency to, you usually own that code for the duration. Like everyone will always come back to you to modify that particular piece of code because you're the one that touched it. And when it comes to things like data handling rules and the fact that we're in a really uncertain world right now where there are lots of new threats that are evolving, new regulations are coming out all the time, different business needs can occur based on what an organization's business model or objectives are or the campaign du jour. If you are not externalizing authorization, then you've got to recode your app to handle this every single time. Now, hopefully the earlier slides that Ken took you through about reputation, revenue, and your own personal data have helped you understand why this problem has relevance. And what we'll be addressing in this final section is why these specific actions will make a difference. So let's get into some practical advice to help you step up your security game. Ken?
Deny all relates to both architectural and technological decisions that can have a tremendous impact on development options and capabilities. And it forms a sort of umbrella over the other 3 imperatives we're discussing, which are more specific ways of reducing implicit trust. The three basic security tenets here start with a zero trust-oriented thinking of denying all access and then gradually lifting barriers for those scenarios you want to allow. This fail-closed model runs counter to prevailing paradigms that grant all access by default and then put rules in place to limit further access.
Yeah, there are a couple of those examples like privileged access management or multi-factor controls there. The use case example on the left of the slide is Google Cloud External Key Manager, or EKM. We thought it'd be valuable to talk about examples of how you can see these imperatives at work in the real world, out in the wild. EKM is a model that allows you to store and manage encryption keys completely outside of GCP, and that reduces the implicit trust associated with using cloud services in the first place. So if you're familiar with GDPR or the Schrems 2 case, the invalidation of Privacy Shield that happened just this summer, then you know that there are clear privacy wins to having a third party in the risk model with this approach too. Our second paradigm on resource-centric controls, most security controls depend on a user's identity, but digital identities go well beyond just a user's avatar. We all have another Google example use case here of BeyondCorp, which is a zero trust security framework that Google has built that shifts the access controls from the perimeter to the identities of the individual devices and users. And the end result of this allows employees to work securely from any location without the need for a traditional VPN.
And this is useful and can be extended further by adding resource identities into the mix. As a developer, one practical way to begin this is always to describe your data using tags or metadata. It's like tagging unlockables in a game so that everything isn't unlocked at once, and you can group and regroup things based on design changes or analytic feedback. You're making it easier for your security or privacy counterparts to write policy that affects the data handling directly. Grand Theft Auto uses resource stats to dictate what scenarios you're presented with, and the options are always contextual. You want the same sort of mindset when designing your own application security. Most practitioners are familiar with, the old Unix rules. I'm a user, I'm a super admin, but these grant too much trust. Think about the Twitter hack that allowed a non-employee to access a customer utility. Considering more attributes about the subject making the request, the resources requested, and using those tags that you've hopefully added, and the environmental factors around the request itself, like we mentioned, was it on an external Wi-Fi, for example, you can get the full context of the situation before granting access.
Yeah, that's very important. The use case example here is Ionic Machina. Machina is an attribute-based decision engine that can gather that contextual information from a variety of different locations. You can look at user roles, you can gather that resource metadata, the tags that you've added, you can capture risk scores, location, so much more to be used in making access decisions. But let's face it, you don't want to be writing and rewriting all of these contextual rules into your application code. That's a disaster. And that's why our last imperative here is to externalize authorization. Most people are familiar with authentication, that castle walls and moat example we were looking at earlier, where you enter in a login and password to get by the gate. But authorization is the often neglected but more important problem to solve. NIST urges the use of authorization, and so do industry firms like Forrester and Gartner. In fact, the definition of external authorization management, or EAM, that you see on the screen here comes from Gartner. Zero trust doesn't mean nothing's trusted, but it does mean that all trust must be earned. And so in a more technical sense, authenticated and authorized, as you can see in this diagram here.
And again, Ionic Machina is our example, partially because we work there, but also because it's one of the things we do best. Integrating the Machina SDK, the same way you'd use something like Stripe or Twilio to abstract payment or messaging logic into a separate layer, it's not only good security, but it makes your life easier. You don't have to become an encryption expert or get caught in an infinite loop of rewriting business logic. You're putting the responsibility for updating policy where it belongs, with the security, privacy, risk, and compliance teams who know them best. And if you work in a small company and happen to wear all of those different hats, you can still make changes in a natural language UI or through machine APIs without recompiling your entire app. Getting comfortable with external authorization unlocks extra time because it can be used at the presentation layer. This is like using an Unreal blueprint to hand off code to a designer, except in this case, you're handing off to policymakers.
Yeah, EAM is really valuable, especially for those support utility breaches we've been discussing. But the outsourcing of a decision doesn't even need to be one related to security. When you make decisions through policy and not code, your decision-making becomes data-driven. You can dynamically change menus. You can make bonus content available just to specific users. The only limit here is really your own imagination. When should you get started? Well, the world's been an uncertain place lately, so now's a really great time to start making decisions through policy and not code. Because don't forget, it's your reputation, your revenue, and your personal data that's on the line. So how do you get started? You can keep these 4 imperatives in mind, and we'll leave you with a few resources to explore.
As we move into the Q&A section of our time together, we'd be happy to share code samples or other resources that would be most valuable to you. Machina SDKs are available for Windows, Linux, Mac, OS X, iOS, and Android, and they support Java, C++, C#, Python, and JavaScript. There's also a command line tool for testing and prototyping.
Thanks, Ken. So the 4 imperatives that we've been talking about today to help you begin using zero trust as a developer are to reduce implicit trust within your application, to design resource-centric controls, create context-aware applications, and externalize authorization. So there's some activity you can see here on the chart. These are just links out to tutorials, sample code, other kinds of descriptions and documentation that can help you get your feet wet with trying out some of these different imperatives. I can attest that it is it's pretty easy to get started. I am not a developer, but I have set up my own Machina tenant, including the command line interface, the CLI that Ken was just talking about. I think that's really interesting for the gaming community because a lot of times you do a lot of rapid prototyping to come up with a workable concept before you want to present it and move a little further. And just like that sound design example where if you're not thinking through what the overall sound design is going to be like for the application, if you're not thinking through how the security is going to function within your app, then you have a lot more challenges down the road when it comes time to moving something into a workable prototype. So luckily, we have Ken here to answer any specific technical questions that you may have. And thanks for being here. Thanks for being at Siege.
All right, everybody. Welcome again to Siege 2020, Virtual Siege. And we have with us right now Christy Smith and Ken Leitner. I'll let you try and guess which is which. But I love the presentation. We had some questions in advance. If you have more questions, you can ask them right now in the chat, or you can join them in a few minutes in our Discord voice channel. A few questions we got. The first one was, how does a small developer plan for security at the very start of game development or at the very start of forming their studio? What should they have in mind?
Me or you, Christy?
Why don't you take a crack at it first?
So I think the most important thing is to get the basics down. Keep all your software up to date with security patches. Make sure you're on the latest Java because Java is a huge source of viruses. And then what you do in terms of your game development, I guess, is a separate question. But just keeping your network secure is the first start. And I guess it depends on what level of security you're looking for. Like for a lot of game studios first starting out, if a design document gets stolen and posted on the web, it's almost good for them. But on the other hand, there are a lot of other things there that are not so good. Employment records, whatever. What a lot of small companies do is just outsource that stuff. So if you can use a payroll service, for example, then you don't have to have any social security numbers on your computers at all, right?
All right, Christy, your turn to tell us the truth.
Yeah, I mean, absolutely. Keeping your systems up to date and patched is really tremendous. I think thinking through one of the most important things that I can advice I can give is to think about who's requesting access to information and resources. So that's not just data itself; it could be services that you use to run things. What those things are. And then thinking about the contexts of how that access should be granted, right? And just thinking through the process of like, do you know what it is that is sensitive information? Do you know what it is that are sensitive services that could potentially cause damage if someone had unauthorized use to it? And just think through that practice. A lot of times what we see is just access is being granted at the highest level to everything, and especially for a small group that might make sense initially, but the larger you get, or thinking through some of the support scenarios we talked about in the presentation can really help. And it's just a question of maybe brainstorming it or thinking it through as you're getting started.
All right, one more question, then we'll move you to the voice chat. We got some small studios that are having to ramp up servers and will have to be expanding their server use. What should they keep in mind in regard to security for those operations?
So my thing on that is watching what's going on the back end. I think most people are kind of aware of, I don't want to be accessible. I mean, it's kind of the mode idea that Christy mentioned earlier. I don't want to be accessible to the outside without some sort of authentication. But then on the back end, you're going to have, it's not going to be one machine. It's going to be a cluster of machines, and they have to talk to each other. And how is that conversation happening? Does that need to be encrypted? Is that in a completely secure, if you're running all those servers on your local area network, you have some level of security there, but chances are they're not running on your local security network. They're running at AWS, and when they talk to each other, it's kind of out in the open, right?
All right. Any other thoughts, Christy?
Yeah, I would say if you're setting up a new, especially if you're using cloud services, I would look into what's called the shared responsibility model. One of the amazing things about cloud services is that they take on doing the security for a lot of operations, mostly the infrastructure and platform layers. But the data layer, where your information sits, clients have a responsibility to protect that. And so a lot of the breaches that you see around misconfigured AWS buckets, for example, S3 buckets, are because, and it's the customer who's actually getting in trouble for this, not the cloud provider, AWS or Google or Microsoft Azure in that sense. And all of them, to varying degrees, have responsibilities that the clients have to take on in order to secure that information. And so I would look into having security that maybe goes beyond just the native controls within that cloud provider. So some of the topics we touched on in this presentation around privacy, if you're dealing with any data that might come from individuals in California with the California Consumer Privacy Act, or with Europe, the European Union, in terms of the General Data Protection Regulation, it's important to think about separating the information that you're protecting from the keys that you're using to secure it.
All right. Invaluable information. Thank you both very much. And we are going to go ahead and head to Crisis Communications for Game Devs with Blaine Humphreys, Kimberly Starks, and Michael Brown. Thank you very much, Christy and Ken.
Thank you.